Introduction to DNS. Since Active Directory relies so heavily on DNS, in today's Windows networks, you not only need a DNS server, but you also need DNS to be reliable, and since so many problems are often attributed to DNS being incorrectly configured, you need to ensure that you get it right. The Domain Name System, or DNS, is a method of resolving IP address to words. For example, 10.0.0.10 could map to the server called mail.winstructorlab.com. Without DNS, we'd be forced to remember lots of numbers in an IP address if we wanted to visit a website. And let's face facts, we'd never remember even 1/100th of the IP addresses of the websites we visit, so DNS saves us the trouble by handling the mapping of names to numbers. Now, a DNS name consists of two parts. The leftmost part is the computer name, and everything else to the right is the domain suffix. So, in this example here, DC01 is the computer name, and winstructorlab.com is the domain suffix. The DNS structure is a hierarchical structure that starts with a root domain designated by a period or a dot. The root domain is operated by a non-profit group called the Internet Corporation for Assigned Names and Numbers, or ICANN, and beneath the root domains are other top-level domains .com, .net, .org, .gov, and so forth, and these are referred to as top-level domains, or TLDs, and the control of these domains at this level have been delegated from ICANN to other companies to manage. So to operate your own domain, such as winstructorlab.com, we would have to pay for a domain name from a domain registrar. And we'd do this by going to any registrar's website and providing some information about ourselves and of course giving them our credit card details, and in return, they'll set aside that domain name and grant you the rights to operate the domain that you paid for. Now, we don't really own the domain, we'll be leasing it, much like renting a house or a car. You can use it for as long as you like, as long as you continue to pay the rent, of course, but you never actually own it. So, as long as we're not infringing on any trademark with our choice of domain name, and of course, as long as we continue to pay for the right to use the domain name, then you can effectively consider it your own. Now, from this point onwards, once we have a domain name under our own control, we can create as many subdomains as we like, and we don't have to ask anyone's permission. We can just create it ourselves. So, if we were to own the winstructorlab.com domain and we wanted to create a new subdomain called sales, then our own DNS servers will be responsible for communicating with that sales subdomain that we're in control of, and we can do anything we like from that point onwards. So let's talk a bit more about how DNS really works. When a user, whether they're down the road or on the opposite end of the world, decides to point their browser to the winstructor.com website, of course, this user's computer doesn't know the IP address of the web server at Winstructor, as that could be practically any IP address, so it can't go directly there. So, the user's computer then asks its local DNS server for the IP address of the Winstructor web server. But what it's really asking for is the server named www. That happens to be in a domain named winstructor.com. Now, at this point, their local DNS server needs to find the DNS server at winstructor.com, which will know the answer. The problem is, your DNS server doesn't know the IP address of the DNS server at winstructor.com either. So what does it do? Well, it's quite simple. It asks the next person that should know. So it goes straight to the .com's parent, which is the root. Now, you might see a problem here. The root is the end of the earth as far as the domain hierarchy goes. It can't go to another DNS server higher up the chain simply because there isn't one. But that's okay, because the Windows 2008 DNS server software comes with what's known as a root hints file. This file contains the name and addresses of all of the 13 servers that comprise the root domain. And this root hints file is a simple text file which is located in your Windows System 32 DNS directory. So this user, who's looking for www.winstructor.com, he's in luck because his DNS server is now able to at least talk to the root domain. So it's going to ask the root domain for the IP address of the DNS servers at the .com domain. Now, a root server doesn't know the IP address of the winstructor.com DNS server simply because it's not responsible for it. So the root server will only send back what it does know about, and that's the last part of the winstructor.com domain, the .com. So the root server will respond with the details for the DNS servers that are responsible for the .com domain. So our local DNS server now knows where to find the .com servers, so the local DNS server can ask the DNS servers at the .com domain for the IP address of the winstructor.com DNS server. Now these .com servers don't know what the IP address of the machine named www in the winstructor.com domain is, but it can tell the local DNS server what the IP address of winstructor.com's domain DNS servers are, because when this domain was registered, we had to supply the IP addresses of our DNS servers. So it's going to reply and tell the local DNS server the IP address of winstructor.com's DNS servers. Now that it has this information, the local DNS server asks the winstructor.com DNS server for the IP address of the computer named www in the winstructor.com domain. The DNS server responds, and the user's local DNS server will cache that name and IP address, and it will send the information back to the user's computer. The user's computer now knows the IP address of the www.winstructor.com server, so it will cache that IP address locally, and then it can contact the web server directly. The web server will then be able to supply the user with its default homepage, and of course the user can now access the website. Now that's the process from scratch, but what if we need to create a subdomain called marketing.winstructor.com, and the marketing department have their own IT staff, which want to control their own DNS? Well, now we're talking about delegation. In all honesty, what we've just discussed is also delegation. The root servers directed you to go to the servers responsible for the .com domain when you wanted to find a .com address. That responsibility was delegated from the root servers to the .com servers. And the .com servers delegated the winstructor.com domain to us. But you can use delegation within your own DNS environment. Now, we don't want to give the marketing department complete control over our entire DNS environment, so we're going to need two things to make this delegation work for our marketing department. Firstly, the marketing.winstructor.com domain will need to have its own DNS server. Secondly, we'll need to create a name server or NS record on our DNS server, which effectively says to any incoming requests, if you want to go to marketing.winstructor.com, then go over to that server and ask them, don't ask me. So what happens is that the marketing.winstructor.com DNS server becomes authoritative for that child domain, just as our DNS server for winstructor.com is authoritative for our parent domain. So if our user out on the internet wants to access a host on the marketing.winstructor.com domain, he'll first contact his own DNS server. The DNS server will contact the DNS server that's authoritative for the winstructor.com domain. This server knows that it isn't responsible for the marketing.winstructor.com domain, but it does know who is responsible, as it has an NS record that tells it to forward all marketing.winstructor.com requests to the server listed in that record. So it sends back the IP address of the DNS server in the marketing.winstructor.com domain. The user's DNS server then contacts the DNS server in the marketing.winstructor.com domain directly and requests the IP address of the host that the user's trying to contact. The marketing.winstructor.com DNS server responds with the host IP address, and the local DNS server caches it locally and then forwards that address to the user's computer. Now, the user's computer will also cache that IP address locally, and then it can contact the host that it's looking for, as it now knows the IP address of the host. And that's the process of delegation. In this video, we've talked about what DNS is, how DNS works, and delegation. Since DNS is such an important service in your network, it's critical that you have a good understanding of how it works, and over the coming videos, we'll not only install DNS and configure it, but we'll also use Network Monitor to capture DNS traffic, so you'll get a first-hand look at what these packets look like when they go back and forth trying to resolve hostnames. We hope you've enjoyed this video and would like to thank you for supporting Winstructor.